Recording.
All right,
Go.
let's go. I'll stop here. macOS just finally installed. Anyway, screw it. Um, is it too big, my image, or do you want me to zoom? I don't want to try because I think it will probably screw up this.
Yeah,
But
hard to tell.
anyway,
Just go. Just go. If
yeah.
it's
All
too
right.
small,
So
are we gonna say?
all right. So let's talk about small talk today. And shut up, macOS. I hope you guys can hear this. Anyway, just
Yeah,
click
we can.
record in the video then.
No, I'm not editing. I'm not editing this
Anyway.
crap out.
Oh man, just shut up. Okay. So let me begin. So how do I begin? So let me talk about the story first. I'll use the browser again just to. So there's this person here called, and I don't know why. This person is Dan Ingles. So he's one of his old computer science people that was in the very early uh, Xerox PARC. So for those who don't know, Xerox PARC was, well, Xerox, I think everybody knows, right? It's literally the company that made like Xerox, like laser printers and all of this. And this was back in the 70s. You gotta have that in mind. So 60s, 70s, like late 60s, I think. So they made a lot of cash just by selling these machines. So it was really revolutionary at the time, like making photocopies and everything. So they were like, they're flooding the company with cash, and they had this section here at the company called Xerox PARC. So Xerox PARC stands for Palo Alto Research Center. So it was like the place where they would gather a lot of nerds just to make them happy by supplying them with infinite money and infinite time to develop whatever they wanted. So that's how the project started to come up, and they made this computer back then. So they came up with this computer. It's called the Xerox Alto because of Palo Alto, California. So they made this one, uh, which which is, well, quite bulky, right? But you gotta remember that, man, we are talking about like late 60s, beginning of the 70s. So it's pretty impressive actually that they could make a computer that, granted, was very expensive, but it was like the first really personal computer at this level. I don't think it was the first at this uh, form factor, but it was certainly one of the first. So back then, they made the computer first, and it didn't have anything. They were just envisioning how the computer would be for something, and they were aiming on the long term. So we are making a computer now that's crazy expensive, but the goal is to just to start developing a very solid foundation. So in 20 years from now, we can sell this thing or something slightly better because the price will be cheaper. Because you got to think that the reminding of the Amdahl's law, right? I don't even remember how to write it. Like by the Amdahl's law, okay, like we were still not in here, right, in this asymptote, but we were increasing in terms of of performance and price rate. So computers were getting cheaper, memory was getting cheaper, a lot of like aspects, components of a computer was getting cheaper. So people just started like envisioning, okay, on the future this is going to be way cheaper, so we can just start laying the foundation right now. So they came up with this, and then a lot of people that were working for companies like NASA. By the way, I'm picking all of this from Xerox PARC, Dealers of Light. Oopsie. Dealers of Lighting. So this is an awesome book. This is an amazing book. It's like a story. It tells the narrative. It goes on a narrative of the story of what happened back in that time. So it basically has the full representation of who the people were involved, who was involved, like what they were making, like all of these things are detailed here. So it's a really good
I
book.
think that Jay Z recommended me that book. I have in
Yeah,
my
he
suggestions list.
recommended this book. That's why. So
Oh,
it's
he
like a
recommended to you.
history.
Okay.
Yeah. So that's awesome. Anyway, so I was listening to this audiobook. That's why I got this idea. So okay, and then like a lot of people that were working with like very big American companies and American the American I wouldn't call NASA a company, but anyway, like some people from NASA that were there. So very brilliant people. They were invited to be part of the park. So they came up with like the ideas to make an interface for this thing. And there's this guy at the same time that was making this dude here. So at this time, he's a educator. So he was like specializing into thinking into studying like a better way to teach kids, like trying to run away a little bit more from the classical. I wouldn't say classical because that's different. Yeah, it is this new form that was like normal at the time to teach kids in class. So I wouldn't say classical because classical is like a Renaissance part of education. So like literally the trivium, and then you have like this intermediary period where you basically have students in a class sitting down. So he was trying to like think of a better way to teach kids with like some interesting remarks. I think he's from South Africa. I might be mistaken. But anyway, so he was very important on this field, on education. I don't know if he passed away already. I know he was very early on this. Anyway, so as he had this legit interest to teach kids. That's it. So they were trying to make an interface focused on teaching kids how to compute stuff. So the first thing they did, which is the book narrates a lot, that's very cool, very descriptively, is that they made a cookie monster, the Sesame Street. So they made a cookie monster. So they literally made this character in the screen. And just think about how amazing this is. Because at the time you have computers that they have like, you have this, man, like pet computer. Yeah, from Commodore. So you have computers like this that they are like, they're cool. Like a lot of people are making games on this, but they are like very, very primitive graphics.
Is that Tetris there?
I don't know where this.
No, the other one that you click, that would be like hilarious. Like we tried to implement it now, like full circle Tetris again.
Well, somebody probably made Tetris for this time. I think in Russia these computers were pretty famous. Japan as well. But anyway, like well, this came later. That's my point. But even so, like, dude, this came later, and it was like a monochrome screen. Still, the Alto also has a monochrome screen, but it's not green. And like they were making this like so far ahead of everybody that it's just literally impressive how they came up with these ideas. So this is the interface that they came up with. Better. So this is the original version of it. And as you guys can see, this is pretty similar to this. Well, we have this macOS thingy here, right? By the way, macOS stole these ideas. Like Steve Jobs literally went there and he said, okay, I like this idea. So he copied the mouse, he copied the whole way the Alto worked. And he basically made the Macintosh out of this. So the interface with everything. So it was just like a copycat of this. But I think he can just copying the thing that would get him to market, but not copying the essence of the thing, which I think is what makes this a whole other level. But anyway, I'll get there. So anyway, so there's the system. So it's pretty cool with the interface. And what is the idea of Smalltalk? Which is both the operating system. It is a language. It's like Nix, like it's a system. It's an operating system. It is the package manager. Anyway, so and a language. So the idea here is that it is a fully interactive operating system. What does that mean? It is like Emacs. So it is like when we open Emacs. Oh man, I don't even have my config here. So it is when you open Emacs and then you start, okay, I wanna dude, what the heck? I wanna like evaluate something. Like, I don't know, 1, 2. Like this is this is a whole interactive system. That means you can change every bit of it while it runs. You don't need to recompile it and keep like opening. that process, right, of batch processing. You go to the terminal, you go to the code, edit it, save, go to the terminal, compile, run, test, go to the code, edit the code, and repeat. It is like interactive in the sense as you write, you can already run things. So it came in as an interpretative language. So it was fairly slow that, well, they mitigated this. They first made the first version of this was made in BASIC. To give you an idea of how slow it was. So anyway, so that's it. Now let me actually go on the thing. And there's this person, right, which is one of my heroes personally. He's one of his old computer people that I think have been largely forgotten, unfortunately, but he holds a special place, especially on classics such as like object-oriented programming, which is, I think, it starts for real with Smalltalk. At least the ideas. Now I think this just got perverted. So okay, this is the interface. So this is Squeak. This is a modern version of what people made to be. Well, this is Squeak.js, right? Thanks to Nathan, we found in a browser. So this is like simulating the Smalltalk environment. So this is as if we are in the auto right now, as if it existed right now, and we are using. So I will open. So you can bring like apps. It's a full operating system. So we can configure, do all that stuff. But for the sake of this presentation of being like 10 hours, I'll just do the basic here. So I'll bring this. So this is the transcript. And I'll bring, I think, workspace. Yes. So okay. So I'll give a quick introduction how it works. So the object model of this is fairly simple. It is basically what we know about inheritance, but focused on message passing. So it is like what we know of Erlang today. So everything that we have here is an object. Even a class is an object. That's a very weird concept from today's standards. So, and you can inspect everything. Everything has, what is the essence of OO, right? It is coupling state with functionality. So it is literally making what an object has. It has the functionality and the state inside of it. So that's the same concept we have here. So let's first start with making an addition, okay? So let's add 1 and 1. And then you end the sentences with dot, okay? So I'll just select this, I'll right click, and then I'll say do it. It did nothing. What the heck? What happened? Tell me what happened, Lemus.
Wait. That was supposed to happen, right? This is not a joke.
No.
Okay.
This is supposed to
So
happen.
I guess you sent a message to no one.
Yes, exactly. I need to print it, right? So there is a thing here to print, and then it shows here. See? But it's quite bad to show the thing here, right? So what I would do is that I would, well, send it somewhere else. So I would say transcript, which is that object up on the other side, and I would say show this thing. So, okay, show to me on transcript this thing. So I'm calling the message show on transcript, which is this object, which is the message 1 plus 1. So evolve this to me and show it here. There it is, 2.
Question.
Go on.
So if you have 1 plus 1 without the transcript show stuff, is that being sent to like a global buffer?
Wait. Repeat the question. Sorry.
Yeah, because I want to know. Okay, you said 1 plus 1 dot, and
Yes.
nothing happened. But is the message being sent to a place that nobody's reading, or the message not being sent at all if you don't put
if I just do 1 plus 1, and
dot.
execute. Well, it is just evaluating, but it's not doing it. I didn't ask it to show to me. It just evaluated. I didn't call any message saying, okay, evaluate and show. Like it is just doing what I said, which is just evaluate.
Okay. So in the hardware level it did, but because you didn't ask for to print or whatever, it didn't show anything. Okay.
So, okay, let's inspect this thing. So this is the transcript. This is this thing here. So we can see, okay, self. We can see implementation of the stuff here. The only bad thing on the browser is that's quite slow, but that's to be expected, right? Can't complain. So last character, it's here. So, and actually, so if I were to guess, I would say probably this thing here. I would have to explore. Let me see. Nope. That was a way. Just sec. I think it is. I don't remember if it's this. I'm just trying here. I think it is.
Dude, what the heck is spy on it? Like, there's an option called spy on it.
Yeah, that's probably like a watchman.
Oh, yes, it's probably like
listen, right?
You can attach a debugger. Dude, this thing has everything. You gotta watch the talk, because I barely know how to use it properly, but you gotta watch the talk of a dude that knows how to use it. You can literally do very abstract things in like so little. That is just insane. There is this thing called browser that I can have listed all my stuff in my operating system, right? So on the auto, you would have kernel numbers, for example, here. And then those are literally the numbers that are there in a hierarchy. So like you have like, okay, you have integers and you have large positive integers, large negative
Is
integers.
that browser itself also there?
Sorry, Nathan?
Is that browser also there?
Is that browser?
Yeah, he's asking like the system browser. You're using the system browser. Can you find the system browser inside the system browser?
I need to. I think I can do. I think I can do this. Just a sec.
Well, I want to know how you do recursion.
I think it is browse. Oh, sorry. This transcript browse. I can browse this thing here. So let me. I think it was this. I might be wrong. Oh, there it is. So this is the transcript screen. So this is the object here.
Yeah, but I mean,
you can see here. Let's see the method I just used, the show. Oh,
yeah,
here.
it is there.
So this is the implementation of show for that one. So I receive an object. This is a function. This is a lambda, actually. I think you can pick it that way. That in this case, I'm not receiving any arguments on this lambda. I don't know this zone. To be fair, I think it's another message that I inherit probably somewhere. I gotta check it out. And then I say, okay, pick this thing here and call this thing with this method as a string. Then end blah blah blah, which is probably implemented here as well. And then by right, or if you
that looks like a try catch.
So this is like probably a try catch, right? Sorry,
yeah. No, that is what he said. It seems like a try catch.
Yeah. So
okay, but I want to know how you do recursion with message passing.
Oh, okay. We can get there. let me just get into the essence of something. Okay.
Okay, go.
Before we go there. So first of all, let me put it here because it's bad to see that way.
That's so interesting.
Did Nathan say something? Increase the volume and can barely hear you guys.
Wait.
Okay. So let's do an arithmetic expression. So 1 plus 1 times 3. What's the result? Let's put 2. What's the result of this?
Well, it should be 7, I guess.
Oh, wait. I decreased the volume. Say it again.
It should be 7.
It should be 7. You're saying it should be 2 times 3, so 6?
Yeah, assuming that it has precedence.
Yes, but you're going to be surprised to see that it actually is 9. So what it did was 1 plus 2, then it's 3 times 3. But that's really weird. Why would it do such a thing, right? But then you remember that everything is an object, and everything that you call like this is a message. It's a method.
Okay, so it's like fourth then. The order matters.
Well, it does, but it is consistent. That's what I'm saying.
No, it is consistent.
It is consistent in terms of... It's the same idea of Lisp, because it is consistent on saying, okay, get 1, get this object one, and then I want to invoke the plus message on 1. And what do I pass to 1? Well, I pass 2. So now this is another number.
Oh, yeah, that's
Is
something
that-
like Lisp, Nugget.
Yeah, but
Yeah,
that's you said something interesting. You're sending to the one the operator plus. Is that what you said?
you're sending to the no, I'm not sending to the one the operator. I'm calling the message plus on the
And I lost what Magetta said there.
This is a number,
Yeah,
and this is an integer to be precise.
yeah.
An integer has a plus. Okay, let's go there.
Yeah, okay, no, but I have so many questions. So can you do partial application with like 1 plus?
Well, I think
What
it will
happens if you
fail
remove? Yeah, that would be
because
interesting.
I'm not passing. This expects one argument. I'm not passing anything to it.
Okay.
It's not like functional programming, man.
No, but I just want to see, like, try to figure out how to imagine that happening in my mind.
I could not find it. I think I don't know. I can take a look there, but I can. If you look into like an object number, a class number, you can see this message here, and then you can see the implementation. But then anyway, it is basically just okay. This call on this method for 1 and pass this as a parameter. Then this whole expression produces another integer, and then this integer I call the message multiplication where I pass 3. So it is like this. If you want to force it, then you do the precedence with parentheses.
Oh man, that's pretty fucking cool, man.
Sorry?
That's pretty fucking cool.
Yeah, but I think what I want to get with this is the consistency of the language. Because I think this is really cool, the fact that you just need to know a little bit on how it works, and then everything follows the same order. So you can already start doing like some very complicated things with this. All right, so this is enough, I guess, for the basics. Let's do. I didn't do functions nor anything, right?
Yeah, but I have a question still about what happened there. So
Okay.
you had a plus, and then you said that, oh, I have a plus and I have the 6, and then you're
Okay.
doing stuff. So my question is it a stack or a queue that we are doing the
No.
message exchanging?
Oh, it is a stack. At a lower level, it is, but you shouldn't think of like, oh, it's gonna be stacking things. At lower level, I mean when it generates the byte code, right? It will be a stack. But my point is, you should think of these as messages that you're passing. So in this sense, it would be, okay, this message for 1. And what is the second expression? Well, it is an expression where I pick the number 2 and I call the method, the message multiplication, then I pass 3 to it. So you shouldn't be thinking like for example, that, okay, I stack 1, stack 2, and then this, right? That's not really the same idea. This will be the bytecode thing to generate this will be the VM, in the modern term. This will be the VM thing to generate the bytecode that will be run.
Yeah, but I'm having a hard time, like, because when you're exchanging messages, somebody's sending something and somebody's receiving something, right?
Yes.
So the stack that I'm calling is the receiver, right? The receiver is grabbing that and it is doing something with that, and it appears to work in a stack manner.
It is doing this. The problem is you're thinking of the implementation. That's the problem I'm mentioning here.
Okay, that's fair. But continue. That answers my question.
Here, like this plus is a method, a message. Sorry. So it is here, and then it receives 1 parameter. So it is like as if it were a function that receives another thing and does something. And there's a whole lot of things here implemented. I don't even know what this is. But anyway, so let's do let's see if we can do a lambda calculus. This is more daring, but let's see if we can do it. I think we can. If I remember some syntax.
From addition to lambda calculus, right?
Let's do lambda objective lambda. That's the name. I think we're gonna fail miserably, but let's try. And I lost it, and it's not ordered. Alphabetize. Let it do its stuff. The only, man, yeah, that's the only bad part of doing this on a browser. It's slow as heck. ST. Wait, I already passed.
Yeah, dude, you're so far. It's like in the middle of the alphabet, I guess. Yeah, there.
Here. So okay, this is my thing. So let's start making a subclass of the class object. So, but by the way, I think I forgot to mention something. The fact that this language is like calls VMs on stuff, it means that your whole project is a VM. It's a virtual machine. What does that mean? It means that it saves the whole context of the computer at the operating system in an image that you just load back. So, for example, I am developing something and I have all my variables, its respective assignments, and all my state. I save this as an image, and then I can go to another computer that runs this thing, like a Squeak, and then I can load it there, and I'm gonna have everything with the correct assignments and everything where I stopped. So this is the concept of images. And if you remember, like Comulisp, the way it compiles, like think of SBCL, depends on the implementation, right? But the SBCL, for example, it compiles to the Fazel type, which is like you can create an image of that. So it is like a Lisp image. It is the analogous to this Smalltalk VM image. So that's the thing you do to load the stuff. Okay, so let's do one thing here. So you start with this hashtag. So let's do a variable, I guess. So what do we do in a variable? Well, first, what do we have inside of a variable? We have just a label, right?
Yeah, I guess a name, a label.
Okay, I think that's it. I don't remember that well. I'm literally being oopsie. How do I?
Yeah, no, this is peak freestyling. Like, there's nothing above this.
Wait. Class variable name. Oh, wait. Instance variable names. Maybe it's here. I don't remember what is the difference, to be fair. But I thought it was the other one.
This category is something like a class, but I guess just like a reminder, not enforcing anything.
Well, everything is a class. Actually, everything is an object here. So this is also an object. And then you have classes inside here. And then you have this is just the sort. This is a hierarchy. So you can make like further categorization for like dividing the actual messages that go here.
Oh, wait. You're creating an object there, right?
Yes.
And you have two different things there. One, you are saying objective lambda, and the other you are saying hashtag variable. What are those?
Wait, just a sec. Just a second. Let me see if I can save this. Because you see this? I need to save this to run. So this gets evaluated here. But how do I save it on the browser? I cannot press Ctrl S. So.
More? You have more.
How do I save it? Accept? Variable is an existing class in the system. Okay.
Okay, so we should definitely rename that.
Let's call it E variable, as we always do. And accept. Okay, now we have here. Go on, Nathan, what do you say?
It complains about lacking comments. That's the most advanced feature I've ever seen.
Yeah, that's really good.
That's fairly important, I guess, right? That's fairly important, but we don't leave like comments here.
Yeah. So how can I say? Like, what is this grouping, right? I was thinking, is this category something like a class in the sense of I'm grouping objects?
Wait, a category, you mean this, right?
Yeah.
Yeah, this is just to group a bunch of these things here. So if I were to make a literal here, let's be consistent, right? Value. And since it's a dynamic language, it doesn't care what is the thing here. So those two things, they are now part of the same scope. which is this object lambda.
Something that to be aware is that I think that in one of them, oh no, both we have instance variable names. Okay, I thought one of them we were using class variable names.
So we can do, what we can do now is a method for initialize. So the thing you can do, like, let me just remember how to do it. I don't recall. Remove method.
Oh, that is remove button.
Oh, here.
Like the fact that you are messing around with other things that are part of the OS, that's pretty cool.
Yes, dude. This is extremely cool. So I am inside a variable, right? So let's do initialize. So this is the way to start. So we can just invoke this from the superclass. So I'll just ignore the comment. Who cares? Super initialize, I think. I think that was it. I might be totally wrong. Type your initials. Okay, who is doing this bullshit? Me? Saved. Okay, this. Maybe it is wrong, okay, because, well, it's dynamic, so I don't know. But let's test. So let's go here. So let's try to start with new, an e variable. And then dot, because I didn't need to pass anything to it. Do it. Undefined. So does not understand, blah, blah, blah. I don't know if it was because of the namespace or it is because, let me just see here real quick. Quick initialize.
While you search that, I thought about a thing. So can we add methods for like categories, like an abstract class? Is that a thing?
Wait, say it again.
So as far as I can tell, a method pertains, like, it's part of an object, right? But in like modern OO, you can have abstract methods. That is, like, you don't have to instantiate a class to use the method.
Yeah.
So I was thinking, can we make the evolve method being like that?
Being on the superclass,
yeah,
like expression. Yes, that's
Isn't that the static method instead of?
Yeah. Sorry, static method. That's probably the correct nomenclature
let's
for
do
that.
something here. So let me go back here. Let's do an expression. So this is what they did. This is inheritance, right? I think they just have inheritance, but you can make like the methods abstract. You don't need to provide an implementation.
Oh, okay.
So let me think here. Quick inheritance.
No, but we're getting ahead of ourselves. Let's take a look on the initialize first.
I remember doing this, man. I just forgot. It is like, you see, oh man, wait. Here. You see these things? You can pass like superclass. Something like this. I think this is wrong, but let's try.
Probably is capital C because there is some convention of naming there.
Oh, wait.
Wow, but subclass is one word.
Oh yeah, subclass is not. It doesn't have a capital C. You're correct.
Yeah. I need to look here. Blah, blah, blah.
The fact that you have just found documentation like that, like immediately, that's.
It has pretty good documentation.
What do you mean?
Yeah, dude. We are talking about the beginning of the computer age for real, and then there's a bunch of documentation like.
There is the paper where they show all they did. Like, for example, on the talk, he shows how they did the number system. And then they said that they didn't have at first like big numbers. But the first thing he discovered was children, they like to play around and they like to mess with big numbers, right? So like they started doing factorial and calling factorial for like a very big number. And then it was like the integer they did wasn't like handling these big numbers. And then what they did is that they quickly extended the operating system by using inheritance to basically make another class called big numbers, something like this. I think I saw it there, right? To make a big number, so like you could just make an arbitrarily big number. So that is pretty cool. The fact that they spent so little actually designing the base of the operating system, then it's very extensible. Like it is crazy intelligent. And then like, so okay, let me go on my critique on the thing that I was going to say, right? On modern WoW. I think like this is a very good example that it was designed, like it has a debugger. It's because I don't know how to use it properly, right? So, and I'm freestyling, I didn't prepare anything. But I think if you know how to use it, like a bit, like I think if I spent a week understanding like some how to debug, how to do some things, I think I can already do like a tiny project on this just fine. Now I like to compare this with like another modern OO language like Java, which took over the OO world, right? This has nothing to do with Java in my opinion, because Java is all about making this static. And to me, like you making this static kills the purpose of having this to begin with. Because the whole magic of this is the thing that you can play around, extend things, create things at like your will, investigate what is inside of them. And the fact that the language is dynamic is precisely for that reason. It is to give you this freedom to toy with the language while you're doing things. So that is a very, and to me that's the true thing. Like when people talk like Richard Stallman, when these people really start talking about GNU and freedom, okay, I give some thumbs up to the idea of like liberating people's computing from oppression. Problem is, I think it's lacking some sort of sympathy to the user, because it's not everybody that uses a computer today that is on the level of somebody that is immersed into Linux and GNU and can freely use it. That's a problem in usability, I know, and a lot of like amazing libraries try to mitigate this issue. Like GNOME, I think is a good example. It has a pretty good interface. My main problem is when you just preach the idea of free software, that is, give me the source code, give me this is just one aspect of the libre, free as in freedom, right? But I think it's a very important one, which is give the source code. It doesn't mean anything to the average person, or not even like to the average person, I would say, but to the person who wants to have your computer as a playground. What I think is liberating is the fact that I can quickly understand the syntax of the language. I can quickly go inside of it, and I can start doing my stuff in it in a way that is like, dude, like as I said, they were doing this for kids. So literally kids were using this. So the interface is not hard to manage, I guess. I don't think it is. Maybe some improvements they here, but I don't think in general it's bad. I think it's very educational, the fact that you can describe objects, and if you know just a bit like how to, okay, which window does, what is the concept of an object, and blah blah blah. You can handle like already some very simple stuff, like very with ease. We are trying to do hard stuff already, right? We're trying to do inheritance and all of this. But for example, this thing here, like this is not hard to understand, I think. So, and I can inspect all of this, like I can browse. So this is to me the real freedom. It is the idea of me going there and feeling that the computer, I have control over the computing. That's the idea of freedom, I guess. I think Richard Stallman puts it somehow, but opinions of this, but he puts it as having full control of your system, and then you can extend that to having the source code and so on. Anyway, so that was my disclaimer.
Yeah, but that's kind of like basically the same argument as using Emacs. You can also argue that for NixOS about having full control.
Yeah, dude, Emacs, by the way, like Lisp, Emacs comes from Lisp machines, right?
Yeah.
So Lisp machines, they're actually a successor for the Smalltalk.
Yeah, that's exactly what I thought.
For artificial intelligence, because people were doing artificial intelligence with Lisp. right? So like there was this company, I forgot the name, Symbolics, this one, that they had these beautiful list machines that had this system that looks exactly like Emacs. And Richard Stallman was at MIT, so this. So it is like Emacs, Control C, Control B here. So anyway, this is something. Is it Emacs or Zmax? I don't know. Anyway, so the whole point is these machines, they inherited this idea from Smalltalk. Like when Smalltalk was already dying, I think Smalltalk, the last version is 80, is from the like beginning of the 80s, but in 76 I think is the major release. I think Smalltalk 76 brought a lot of like these things already done. And dude, we are talking about 76. What do we have in 76? We have COBOL, we have scratches of C. No, sorry. C came in 79, right? If I'm not mistaken. No, sorry. C is from 67, right? 69.
I don't know the dates, but
Yeah,
something that
C
I
is
want to
from
pay that
69
I think
because
it's
the
important is
Unix was
that
built in
you
70s.
can literally see the decline, right? Because in Smalltalk, the interaction with the operating system is still kind of like, I'm not gonna say it's the prettiest thing in the world, but
But
it
it
is still
is.
graphics. In
Yes.
Emacs, it is already dumping down to code.
Yes. I totally subscribe to this. I think this is a massive problem, and that goes back to what I said. I think this is lack of sympathy to the user. You can do some tooling like this to browse objects on Emacs.
Yeah, for sure.
I think you can actually do it, but it's way much more complicated than just clicking. Dude, like I literally most of the time I was clicking on stuff. Everything is documented. Like this is to me is having sympathy for the user.
Yeah,
This
it
is the
complains about not being documented, so.
well,
Uh...
I don't document stuff, but anyway. Anyways, that's it. I don't know if I have much more to say. It was more of a philosophical talk. We can try to do something here, but I think we're just gonna embarrass
Yeah, the
ourselves.
only thing that I would like to see is like how you do message passing with functions and possibly recursion. So if you can Google that, that would be cool.
How to do message passing with functions.
Yeah, if I want to
Object.
pass if I want to pass from the workspace to transcript a function that picks two
Yeah, you can do it. Let's do one here.
Okay.
Oh, changes not being saved. Blah blah blah. Whatever.
Because it said that everything is an object, so I'm assuming a function is also an
Yeah,
object.
it is also. Let's do one here. So I don't remember how to do a function.
Yeah, well, it is well documented, so just search for it.
Yes. So let's do. Let's see. Tell me a thing to curry. Like I think you want to curry something like this, right?
Yeah, I want to see like if we can see some sprinkles, some like the initial steps of Rush application stuff.
Yeah, I guess there are a few problems. Like the question is, can you treat methods as like their own thing? And I guess you can't.
No, but that's if everything is an object, you should
Methods?
be able to.
No, but okay. Nathan is concerned about me being able to pass this, right?
Well, not only initialize, but whatever method we decide to create.
This, I don't know if you can pass this. I know you can pass a lambda, like a function like with this.
Yeah, but that's what my intention. I wanted to make a lambda.
Yeah, this I think you can pass. What do I do with this? Let's just do fun. I don't know, man. 1. And let's do transcribe.
Lemus, maybe if you do something like passing the object and the name of the method you want to call from it, maybe that works as a
No. Yeah, but that makes sense. But I want to see if a lambda is treated like as a first-class citizen with everything
I don't think you have a lambda, dude.
No, we do. It's like analogous to a lambda. It's not they don't call it lambda.
Yeah, they don't call lambda. So, like it's in Rust they don't call lambda.
You are
They call
saying
closures. So.
You have a piece of code that does computation and stuff that is not associated to an object?
Here, this thing. So this is an object method that does this, you see? So I'm literally just trying to transcribe this transcript with hello. And then you can pass an argument. So arg, and then if this like finishes the
Yeah,
argument,
this smells like a lambda.
it is.
It quacks like a lambda.
It is it's quad. Why can't I copy? What the heck? Okay, I can't copy. Thank you, Linux. Anyway, let's just do it here. So, let's do it outside, right?
Yeah, you don't even need to be in the system browser. Yeah, one thing too that I also am kind of concerned is that at the same time that is kind of cool that you can create stuff alongside the OS, that's really dangerous. Like you can mess things up. Like
you can just restore the image, right?
Yeah, for sure, but that you can do a git
no,
go
but
back.
Here's the oh, by the way, you have Git integrated with the desktop version.
There's no way.
You have Git here. This is how you
Holy shit, we can stop.
Oh, these are the packages, like how you install libraries, by the way. So let's see if we have the OpenGL thing. I think it was Morph.
That's much cooler than the things we use.
I think it was Morphic.
There's graphics there.
No, it was like OpenGL. Let me see. Probably we need to just put the REPL here. Let me see.
By the way, Magenta, the thing that you showed kind of looks something like I want this method with these arguments, but I will pass the object later.
Wait, say it again.
According to the Stack Overflow, I don't think so, Nathan. I think it's the spiritual.
No, I said it looks like.
No, but for me it looks like a lambda, not a passing object. But we need to check the post for sure. Double check.
Yeah, we don't have here, but well, I think it's because we are on the browser, right? Why would I have the OpenGL? That'd be strange. Or maybe we just need to add the thing here. Maybe with this backport.
Environments. Yeah, that's kind of cool. But let's try the function thing. I'm super curious about it.
Wait, it's JavaScript. It's monothreaded. Okay, so let's see. What was Nathan saying, by the way?
Yeah, I was saying that the thing that you were showing there, for me, oh no, but you are passing to the show, right?
Yeah.
Yeah, it's being here, right?
Yeah,
I was saying that as you have like object method there and stuff, it looks like you were doing something like I'm selecting the method, the arguments, but I'm passing the object later.
Yeah, you're passing this as an argument to this. And then this is a function, and then you just call it with a...
Yeah, no, but Nathan's understanding was that you were passing the method of a future object that you're gonna send later.
Wait, Magenta. So object, it's the object, and method, it's... Wait, oh, that would be
the method is the message for this.
No. You said that you are calling this thing there, object method, with the things after the column, right?
Yeah, this is a way to pass the arguments.
Okay, so can you highlight there, what is the object, what is the method, and what is the argument?
The object should be this. So that's really easy. The method is this, and the argument is this.
Oh wait, that's
then Nathan is correct.
Code, right?
No, but then Nathan is correct. You do need to have always an interaction between an object and a method. You cannot do just method.
No,
that's what I was saying about the passing it, because the methods, I don't think they are objects.
Oh, I see.
Magenta.
Conversation, right? You need to do, well, that's why it's small talk. You need to do a conversation between this thing and the thing that you're putting here. So
my question is, the thing that is there on the Stack Overflow thing.
Go on. Say it again.
Do you know if that's just some abstract code, like full bar? The guy is just like
choosing like
some like placeholders.
Yeah, they're just placeholders.
Oh, okay.
Yeah,
it would be really fun if you had the object, and you had a method called method, right?
No, that would be mean.
That would be like 10 out of 10.
I just wanted to... This is the thing we can install, but I don't think I can install on the browser. Even if I can, this wouldn't run.
Yeah, that would not be a great idea.
But
yeah, okay. So we're gonna have to choose a method and then an object in order to pass a lambda. Is that correct?
No. Yes.
Okay.
Okay, thank you. So yes, we have a lot of stuff here. Snapshot browser. So anyway, we're not gonna be doing this now. Bye bye. So let's just do it here. So arg. So this. I think it was like this, the syntax.
Yeah, and then transcript to whatever.
No. It is the colon first.
Oh, so it's a Lisp style.
I think it is for avoiding recursion on the parser. And then they are doing transcribe. Let's do the same. Script to arg. And then dot. So if you just do it.
No, but that's the thing. From my understanding, that shouldn't work.
Yes.
Okay.
So now we need to pass arg 1.
Wait, if this works, I think I got it wrong before. Unknown selector, please confirm. Are you sure the column is in the correct place there? Because the second time the column is...
I think it is not how I call it. Let me see. Quick function call. How do I invoke a quick method?
No, but that's the thing that we were discussing before. I think Nathan and I, we don't believe you can just call a function. You need to call that inside a method of an object.
No, dude. What I'm saying is, this I know you can call this. You cannot call this loose. You need to call the object that has this.
Yeah.
But this you can call, because this itself is already an object. Okay,
so functions are objects then.
Perform... Was it like this? No, man, it wasn't like this. There was a way to call it, dude. I was watching classes from a dude online. I forgot his channel, man. I should reference.
I have another question though. Can you pass from 2 different places to the same thing?
From 2 different places to the same thing?
Yeah, you have you have 3 windows. One of them is sending to the middle one the function, and the other one is sending the argument.
Wait. Say it again.
Like you have 3 windows, and then 2 out of the 3 will be sending to the middle one, right? Then one of them will send to the transcript a function.
Okay.
And then, but that function expects an argument, and then the argument comes from the other window. Like it's kind of like parallel, like things working.
Objects. So as long as you already have initial place where you start the chain, I think you can.
Yeah, that would be pretty cool. I don't know how you would do that because...
For example, this shit here. Let's see. Wait. Shouldn't curse on the interwebs, right? This.
Yeah, so
I'm expecting this browser. I'm expecting that thing. And this is all it has there. So... Oh man, shut up, Quest.
Oh, this is Siri then.
Yes, you know Siri. It is Siri because I just installed and then I didn't like.
Yeah.
So, okay, I can make a new thing here. I don't remember how to do it though here, but I can assign making one of these, and then I can just give a value, and then this would be a value on this window, and then from a value on this window I can do send, which is like send to this by sending like an intermediary.
Oh wait, so you have to chain them. They can't happen at the same time.
If I have to chain them. Well, at the same time, what do you mean at the same time?
Like, what I mean is like, I'm not gonna use the wrong abstractions, but that's just my understanding. So I want to send to the transcript window a function, but I'm not gonna send the argument. Yeah. And then in the other window, in the system browser one, I'm going to send a transcript a number, which is the argument for that function that the other window sent.
Oh, I see what you mean. Like you want to send the function into one, and then to the same object you want to send now the... to execute, to be
Yeah,
executed.
we have 3 objects, and then 2 of them are sending different things that interact with each other to the third one.
Well, yes, it's dynamic, right? So even if I insert something that does not have a reference, for example, let's suppose I need both, right? I have 2 members here, like arg, fun, and then the fun calls the arg. Let's say the value. It's not a method. Sorry, the arg value from this, right? That I need to assign. I need to set.
Mm-hmm.
Then I can do the set from one window and pass the function on the other, because the reference for the object is only one, right? So both have access to it.
Okay. So
Here they call it blocks. That's not really function. That's not precise. That's true. Because here, let me increase the screen.
There's a factorial there. That's cool.
Here. So this is basically start these variables to me, and then assign to x this thing here, and then with x, let me see. So they're just assigning y and z with 1 and 2 for these things inside this scope. Okay, this has 2 arguments. So, and then he's assigning to x this arg1, arg2. I think this is just to concatenate. Yeah, this is like break the line. So like carry return. So then you just print. So you convert those 2 things to strings with an end.
Wait, I have a question. So this syntax, like x colon equal, is this like an assignment?
X colon.
Yeah, in the beginning of each line we have like x colon.
Assignment. Yeah, this is assignment, and equality is just one thing.
So this block looks like a object with one method, right? And you can use it to be a lambda or something.
Yeah.
Wait, but it is an object with only one method. The method would be x, or is the object x?
Is
X is the object, right?
Yes.
Oh, okay. So it is an wait. So
Here
x is an object.
It has this thing that is getting the value out of x, which is this.
Oh, so the name of the method on x is value.
The name of the full name for this, yes, but this is not a function, right? This is just a block.
Yeah, no, that's a block using the correct nomenclature.
Like a lambda, like this is taking 2 things and then it just composes this string.
Okay, so
and then to run it, what you do is x and then value first, value second, and then you're passing the arguments. That's how you call it. So let's do it here. So
weird.
Here.
That's really weird.
Well, it is, but.
By the way, there is also a thing. I think it's something like that. I don't remember if it's block or if it's proc, but there is something that sounds like that in Ruby.
I think. Oh man, do I need assignment? That would be cringe. But I remember not needing to do it. Just a sec.
Yeah, dude, take a look on this.
Here.
Okay, so there is a thing in the Ruby docs.
Oh, I know the Rubbies, they took a lot from here. Nothing more expected. Is that it? Maybe that is wrong. Yes, it is. So I think we can do this.
What is the first line there with the pipes with the x in the middle? What does that mean?
That it means introduce. Yeah, this works. Like just running this, it works as well. But this means introduce this variable x in this scope that I'm going to be running. And then you can assign this to x, you see?
That's like initializing variable and then defining.
Yeah.
Okay, so then the block is an object because you tested without doing the x stuff and it worked.
Yes, like the thumb rule is that everything is an object. So it is.
Yeah, but it's super weird.
Not everything, right? Because there are things inside objects that are not objects.
Yeah, but even if it's a function, the name is value of the method. That's super weird.
Let's see this factorial. So we're making receive n, and then as long as n is greater than 1, if this
who needs else? That's the correct conclusion. Who needs else, dudes?
No, because these are messages, right? So you pass in the message, is this if true? So is this true? If this is true, then you do this. If this is false, you do this.
Wait, but is that thing lazy then?
Well, it is dynamic, so I think it's easier to do it.
Wait.
And that doesn't answer my question.
Yeah,
I
your
don't need to have
question
this
is
reference existing at the moment to do it, to declare this.
in which sense you mean that the thing is lazy, Nathan?
Well, because you have you have there two cases, right? That happens based on something, like this n being something.
Mm-hmm.
Then you have the two possibilities. If you do that computation, like already, then that's a problem, right?
Yeah.
Well, I don't think I got it.
Wait. If you do this computation that I'm highlighting,
Wait. Because if you do the following, if you assert what the n is, and then evaluate both if true and if false, and then you choose what to do, right? Then that's a problem,
wait.
right?
First, that's not an if. That's the first thing. This is a message saying if this thing is true. So you evolve this thing, and then you say this thing is greater than 1. So like, I don't know, I passed 3 here. So 3 is greater than 1. Yes. So what do I compute? I compute this. That is 3 and the factorial, which is the reference.
Wait. I guess the brackets there. Maybe they are telling something to us.
This?
Yeah. Maybe that's something like not execute at, and then the Boolean object is receiving, and then we'll call it or something, right? Because like the conditional there is generating a Boolean, right?
Compute something else.
Hmm?
This is starting a block to compute something else that wasn't computed yet. I think that's what you mean by laziness, right?
Yeah, because for example, the condition will generate a Boolean, right? So depending on what Boolean it is, it will implement like in a different way the if true or if false, right? I guess that's how you know what to call it. But the thing is, what is between brackets is being passed as something unevaluated, right? That then
Oh yeah.
Oh,
the
in
Boolean will
that
use.
sense, you're
Yes.
talking about
Yeah.
being lazy.
Yeah,
Oh, I
so it
see.
is lazy, I guess.
Yeah.
Yeah, it doesn't have any problems with self-reference as well. That's
Yeah.
kind
Oh,
of.
and that's like a block, but with no arguments, right? So that's
Yes.
the same thing as we do like in Nekoma and shit, man. Like when we want something lazy, we just do a function that receives unit, right? That's the same thing.
Yeah, I can see the parallel. Yeah.
I can't see the parallel. Can you repeat that?
When you want to do, for example, a function, when you want to do something lazy, what do you
No,
do?
no, but that part I got. If you're not using Haskell and you are in Okemo or F sharp, I assume, you just create a lambda that receives unit.
Yes. So this is the same thing. It is like a lambda that receives unit.
Like a block with no argument.
Oh, I see. It's because I forgot that here unit is nothing. You put nothing there.
Yeah.
Oh, I see, I see.
Blocks are very interesting.
Yeah. The syntax is not. I think it may seem intimidating at first, but it's really not. I think when you get used to it. Oh, this is the perform. So how to call a thing. So
Oh, like dynamically you choose the method, right?
so square root of
Oh,
2.
that's great.
Transcript blah blah blah. Perform square root.
That's like apply, right?
Mm-hmm. So indirect method invocation.
So yeah, you can do something like the arguments that I will receive will be like an object, and let's suppose it's a string, right? And then inside I call that object and call the method with that string, right?
Mm-hmm. To access, this is a dictionary, but I know that enumerables, they work on the same way. You access positions with at. So on the dictionary, you access by the key, right? So at, and I think this is for character. So access on the character A, B, and C. Oh, here. So it's using this lowercase, blah, blah, blah.
Man,
So,
although you already told me to not imagine like that, that I should be thinking about message passing and exchanging messages or whatever, this is so forced to me. Like, My mind
Yeah,
is like.
it really does look like. I gotta agree.
I can't really see.
See what?
Here, so X,
I
wait,
can't see how.
Yeah, it's easy. You put the stuff that the next message will influence on. Like you have X, you put X, you send X first, and then you send size next because you want to know the size of X, right? The same thing applied to the Boolean before, right? So you did a Boolean condition, and then you do if through, and then if that's true, that is using the Boolean that is already like gathered there.
yeah,
That's
but it's
so
Yeah,
far
not
to
in
me.
some arbitrary stack, right? It
but
is on the
Yeah,
object. That's
exactly.
really
That is the thing. It's not an
lemons.
arbitrary stack.
But yeah, if you say that for a method call that has always like the same items, right? And then you can say that for anything. Like
No,
for
not at all.
example,
No,
a
not at all.
function application. How is a function application different than that then?
well,
You can just say it's true. I pass the function, then the argument, they are both on the stack, then they execute like.
No, but the order is totally different when you do a function application, right? You pass
Hmm.
the procedure first and then the arguments. Here is the opposite, exactly as in Forth. You pass the arguments first, and then you pass the functions.
Huh? Wait,
Yeah.
wait, that doesn't look like that to me. For example, you have the object, the method that you want to call from it, and the arguments. Like, the arguments are the last thing.
The arguments are the last thing. Oh no, but then you mean when you have like a method that receives arguments, right? I'm talking just for the examples there. Like you have x and then you have size. My mind is saying, oh, I'm grabbing x that is already there and applying size to it. But you're correct.
Oh,
You're sending the object first. In that sense, I
yeah.
see. You're
But it
sending.
is funny if you think, because if you have object and method, like, and that's already calling because suppose you don't have like arguments and such, the
Mm-hmm.
method will have the object itself as an argument.
Yeah, if you.
Your this or
Yeah,
self.
you're thinking like, oh, object and then method and then.
oh, dude, look. Let's think of how to make interfaces, right? So there is this thing, rectangle, that it basically, if I do it, it basically, you see my cursor changed, and then I
Yeah.
can just click and drag. And then it did nothing. But let's see what it is actually doing when I transcript. Here. So it is picking the points in my screen. So it prints.
Oh.
So dude, this is for games is useful because well, you can
Yeah,
just
now I understand how the guy
you
made
understand.
the video that you sent there. Yeah, okay, this is pretty cool. We're already past an hour here, so I think
Yeah.
we're. Do you have any more questions, Nathan?
Not that I can
Yes.
remember.
Okay, I also don't have any questions. It is pretty cool. It is the like one of the primal Emacs philosophy things. So that's pretty cool, and I'm gonna finish the recording now.
Totally freestyle, man.